Ever wondered how programming was done before structured programming languages were introduced? Let's step back in time to the early days of software development. Back then, the go-to method of programming was what we now call unstructured programming. Unstructured programming, as the name suggests, lacks the formal structure we're accustomed to in modern languages. Instead, it involves directly controlling the flow of execution through GOTOs and jumps. Imagine a bustling city with no traffic signals, no pedestrian crossings, no road signs, but just a jumble of roads and pathways. That's unstructured programming for you. A universe of code where the control can jump from one part to another without any predefined order or structure. In the early days, when programming was still in its infancy, this method worked wonders. It gave programmers the freedom to code without being confined by the rules of structure. They could control the execution flow with commands like goto and jump. Goto, as the name suggests, allows the control to leap from one place to another within the program, creating a kind of free-flowing dance of commands and executions. Just like our city analogy, unstructured programming can seem chaotic and confusing, especially to those used to structured languages. But it was this very chaos that gave birth to the concept of structured programming. Developers realized the need for a more organized approach to manage the increasing complexity of software. So, while unstructured programming may seem like a relic of the past, it has played a key role in shaping the programming world as we know it today. It's like the Wild West of the programming world, a place of freedom and chaos that ultimately led to the creation of the structured towns and cities we now inhabit. So, as we journey through the history and intricacies of unstructured programming, remember this: it's not just about understanding a different coding approach, but appreciating the evolution of programming as a discipline. Now that we've introduced unstructured programming, let's delve deeper into what it entails. What makes unstructured programming unique, you ask? Well, let's dive right in and explore its intriguing features. Unstructured programming, as the name suggests, is a style of programming that doesn't follow a specific pre-defined structure. Instead, it affords coders the liberty to write programs in a free-form manner, without the need for explicit control structures that structured programming languages typically require. One of the most distinguishing features of unstructured programming is the use of goto statements. In other programming paradigms, the flow of control is typically managed through loops, conditionals, and functions. But in unstructured programming, the goto statement is used to jump to any part of the code, giving programmers direct control over the flow of execution. You might think of it as a leap of faith where the programmer knows precisely where they'll land. This level of flexibility and control can be both a blessing and a curse. On the one hand, it allows for a fine level of detail and customization that might be harder to achieve with structured programming. On the other hand, it can lead to what's known as spaghetti code, where the program's flow becomes so tangled and complex that it's hard to follow or maintain. Another key feature of unstructured programming is its simplicity. Since there are no formal structures or rules to follow, the syntax is typically straightforward and easy to learn. This makes it an accessible entry point for beginners looking to dip their toes into the world of programming. However, it's worth noting that this simplicity can also lead to complexity in larger projects. Without the discipline of structures and modular design, unstructured code can quickly become bloated and difficult to manage. In essence, unstructured programming is like the Wild West of coding. There are few rules, a lot of freedom, and an open horizon for creativity. It's a style that demands a clear vision, careful planning, and the ability to navigate potential chaos. These features make unstructured programming an interesting and challenging approach to coding. It's time to look at some code examples in unstructured programming. Let's start with a simple example using a goto statement. Consider the task of printing the numbers 1 to 5. In unstructured programming, we might write it like this. We begin with an integer variable, let's call it count, initialized to 1. Then we have a label, let's call it start. This is where we'll jump back to repeat our code. After the label, we print the value of count. Then we increment count by 1. Now we have a condition that checks if count is less than or equal to 5. If it is, we use the goto statement to jump back to the start label. If count is greater than 5, We skip the GOTO statement and the program ends. Now, let's look at a more complex example, a simple loop that sums the numbers from 1 to 10. Again, we use a GOTO statement and a label. We start with two integer variables, sum and num. Sum is initialized to 0 and num to 1. We have a label called loop. After the label, we add num to sum. We then increment num by 1. Now we check if num is less than or equal to 10. If it is, we jump back to the loop label with a GOTO statement. If num is greater than 10, we skip the GOTO statement and the program ends. These examples demonstrate how GOTO statements can be used to control the flow of a program in unstructured programming. However, you might notice that this way of programming can become confusing and difficult to manage as the program grows in size. This is one of the reasons why structured programming, where the flow of the program is more explicit and easier to follow, became more popular. But remember, understanding unstructured programming can still be useful. It gives us insight into how programs were written in the early days of programming, and it can help us appreciate the benefits of more modern programming approaches. These examples should give you a clear picture of how unstructured programming works. Everything has its upsides and downsides, and unstructured programming is no exception. Let's dive into the benefits of unstructured programming first. One of the most significant advantages is the level of control it provides. Unlike structured programming, where you're often bound by the rules and constraints of the programming language, unstructured programming allows you more direct control over the system. This means you can tweak and tailor the program to your specific needs, which can be particularly beneficial for highly specialized tasks. Another plus is its simplicity. For small tasks or projects, unstructured programming can be a quick and easy solution. There's no need to worry about complex structures or frameworks. You just write the code, line by line, until you've achieved your goal. This makes it an excellent choice for beginners who are still getting to grips with the basics of programming. But, like a coin with two sides, unstructured programming also has its drawbacks. One of the most prominent is the difficulty in understanding and maintaining unstructured code. Without a clear structure or organization, the code can quickly become messy and confusing, especially as it grows in size. This can make it challenging to debug, update, or even understand the code if you're not the one who originally wrote it. Moreover, for large projects, unstructured programming is often impractical. As your codebase expands, the lack of structure can lead to a lot of repetition and inefficiency. It's hard to keep track of what each part of the code is doing, and even harder to ensure that all the different parts work together seamlessly. This is why, for larger, more complex projects, structured programming is generally the preferred approach. In conclusion, unstructured programming offers a high level of control and simplicity, making it a good choice for small tasks and beginner programmers. However, its lack of structure can lead to confusion and inefficiency, particularly in larger projects. So, while unstructured programming has its place, it's clear why structured programming has become the norm. Let's quickly recap what we've learned about unstructured programming. We started our journey by defining unstructured programming. It's essentially a primitive form of programming that doesn't use control structures like loops or functions. Instead, it relies on GOTO statements, which can jump around the code, leading to what's often referred to as spaghetti code. We then explored the features of unstructured programming. We learned that it's simple and straightforward, often used in early programming. However, with simplicity comes complexity. Because unstructured programming lacks the structured approach of modern programming paradigms, it can become incredibly convoluted, especially in larger code bases. Our exploration wouldn't have been complete without rolling up our sleeves and diving into some code examples. We saw firsthand how unstructured code looks and behaves, noting the absence of functions or loops and the presence of GOTO statements. We observed how the flow of the code isn't linear, but instead jumps around to different parts of the codebase, guided by these GOTO statements. We also discussed the pros and cons of unstructured programming. On the plus side, it's simple to understand and use, especially for beginners. However, its simplicity is a double-edged sword. As programs grow in size and complexity, maintaining and debugging unstructured code can become a mammoth task. This challenge is further exacerbated by the lack of modularity and reusability, which are hallmarks of modern structured programming. While unstructured programming might seem outdated, understanding it can give us a deeper appreciation for the evolution of programming. It helps us understand how far we've come and the strides we've made in making programming more efficient, maintainable, and scalable. It's a crucial piece of the programming history puzzle, and understanding it can provide valuable insights into the foundational principles of coding. So, as we wrap up our exploration of unstructured programming, remember, every step in our journey, every line of code we write, brings us closer to mastering the art and science of programming. So, keep exploring and happy coding.